Next preparation method, by the catalytic reduction of carbonyl compounds. By catalytic reduction of carbonyl compounds. Aldehydes are ketones. See this, aldehyde are ketone. Aldehyde are ketone. When added with H2 palladium and carbon, catalytic reduction gives alcohol. With ketone also alcohol, but a 2-degree alcohol. 2-degree alcohol. Remember the reagent H2 in the presence of palladium and carbon. Catalytic reduction. Next preparation method, by catalytic reduction of carbonyl compound. Let us see the shortcut mechanism like in the last class. See the shortcut mechanism. Hydrogen to oxygen, hydrogen to carbon. Same shortcut mechanism like yesterday's class, right? Here H and here H, so I can write CH2. I can write CH2. Where we have seen this shortcut mechanism, with which reagent, tell me? Lithium aluminum hydride and sodium borohydride. Same mechanism only, with the lithium aluminum hydride and sodium borohydride. Correct? So when you add H2 palladium to carbon, what you have to do? Add hydrogen to oxygen and hydrogen to carbon and remove double bond. Double bond will convert it to single bond. During addition, double bond will convert it to single bond. Clear? Right. Shall we go to next page? Shall we go to next page? Okay, let us write one important point, very important point, or important note. Lithium aluminum hydride or sodium borohydride do not reduce double bond or triple bond. Very important. They reduce only CHO group or keto group. Okay, both. I am talking about both the reagents. Once again, I will revise yesterday's reaction, and I will give you one important example. Clear? Next, another note. See what I am saying, double bond is not reduced by lithium aluminum hydride. Double bond is not reduced by sodium borohydride. But one exceptional, very important exceptional case we have. When double bond is adjacent to benzene ring. When double bond is adjacent to benzene ring, that will be reduced by lithium aluminum hydride only, not with sodium borohydride. Okay, slowly you will get what I am going to explain. Clear? First of all, you write the note. But when double bond is present adjacent to benzene ring, it will be reduced by LiAlH4. Very important statement. Actually, double bond won't reduced by lithium aluminum hydride, but when double bond is present adjacent to benzene ring, then it will be reduced. Let us see the example. I'll revise yesterday's example along with this exceptional case. Right. Shall I go to next page? Once again, I am giving yesterday's examples. All of you look at this. Some students didn't listen yesterday's class. All of you look at this. LiAlH4 or NaBH4. See this, very simple shortcut mechanism. Hydrogen will be added to oxygen and hydrogen will be added to carbon and double bond will convert it to single bond. During addition, double bond will disappear. So what we will get? We will get CH3 COH, here one H and here one H. So I can write CH2. This is shortcut mechanism with the lithium aluminum hydride or sodium borohydride. Clear? Right. Once look at this, all of you. Once read this. Meenakshi, read this. Right? Look at this. This is 7-member ring. If you don't know how to draw 7-member ring, then draw 6-member ring, nothing will happen. Others, please respond. Are you listening, everybody? Others. Other students, please respond, everyone. H2 palladium or nickel reduction. First year reaction, this is first year alkenes. Based on the previous note, lithium aluminum hydride, sodium borohydride do not reduce double bond. So the product is this group only reduced. See, all of you new students means those who didn't listen yesterday. One H here and one H here with these two reagents. So what is the product here? OH, double bond will remain. Very important example. Here also. Double bond will remain. Only carbonyl group will be reduced. I given one note. Correct only na? Lithium aluminum hydride do not reduce double bond. Clear? But H2 palladium, it is a powerful reducing agent. This is first year example. It can reduce double bond also. Sabatier-Sanderens reaction in alkenes, clear. So it reduces this part and this part. Very important example. See, here two hydrogens will be added. H and H, so double bond will vanish. You know, normal hydrogenation, look at this, all of you, CH2 double bond, CH2 plus H2, nickel, platinum, palladium. You know already this reaction, two hydrogens will be added, one hydrogen here and one hydrogen here. Double bond will vanish. Similarly, here one hydrogen, here one hydrogen, so double bond will vanish. Okay, and this group, keto group converted to OH. Most important example, given the differentiation between three reagents. Got it, all of you? This is first year reaction. This part is first year. Clear, everybody? Okay. Any doubt? Any doubt? Next. What is second note? What is second note? Can you read second note? Reduced by LiAlH4. See, this is also called beta aryl. Why it is called beta aryl? Look at this. This is functional group, CHO functional group, alpha position, beta position. In beta position aryl group, aryl, this is called aryl group. So this total compound is called as beta aryl compound. Why it is called beta aryl? This is functional group. Next position is alpha position, next is beta. In beta aryl is attached. Aryl is attached in beta position. So this is beta aryl compound. In beta position aryl group is present. Okay, or you can remember like this. See, double bond is present adjacent to benzene ring. In that case, double bond will be reduced. H and H will be added, and this also reduced. Okay, now see, all of you, here H and here H, so OH, H, here H and here H, because lithium aluminum hydride reduce double bond when it is present adjacent to benzene ring. So product is CH2, CH2. Why? Because two hydrogens will be added here. Next, COH, CH2. Oxygen, see, look at this. Oxygen will get one hydrogen and carbon will get another hydrogen. That's why CH2, here OH. Most important example this is. Right? You tell me, yesterday I explained, what about sodium borohydride? It is a powerful reducing agent or weak reducing agent? What is the nature of weak reducing agent? So it won't reduce double bond even though it is in conjugation with benzene ring or adjacent in a benzene ring, adjacent position with the benzene. It is a weak, so it won't be disturbed. Double bond still present because it is a weak reducing agent. Only carbonyl group will be reduced. Only this group will be reduced. This will retain as it is. Most important example. Next. Next preparation method. Preparation of alcohols from alkanes. Preparation of alcohols from alkanes. See one condition, alkanes with 3-degree hydrogen, tertiary hydrogen. This is the condition. Not all alkanes produce alcohols. Alkanes with tertiary hydrogen only produce alcohols when treated with KMNO4, a strong oxidizing agent. When treated with the KMNO4. I am taking this alkane. What is its name? What is its name? What is its name? No. Select the longest chain. 2-methyl propane. This one only. This is simple compound. 2-methyl propane. Just I wrote like this. 2-methyl propane. Second position methyl group is there. 1, 2, 3. 2-methyl propane. Look at this. What happens when we treat this with KMnO4? When we treat alkane with a tertiary hydrogen, what will happen? Look at this, all of you. KMnO4 is a good oxidizing agent. It releases oxygen. And that oxygen will insert in between carbon and hydrogen. It is a good oxidizing agent. Oxygen will be inserted between carbon and hydrogen. See, alcohol is produced. Only one method from the alkanes, because we should have condition, right? That's why limited example, only one example. Completed. Next preparation method, by using Grignard reagent and carbonyl compounds. Most important preparation method. Okay. Next, by using RMGX, Grignard reagent and carbonyl compound, aldehyde or ketone. Next preparation method. First, listen, all of you, listen to the mechanism carefully. Here we should do complete mechanism, not shortcut mechanism. Complete mechanism also very easy. Okay, important and very easy. Clear? No need to by heart. If you listen, stop writing and listen. This is very easy. Okay, you have to listen. If you listen and write, then you won't understand. Okay, first listen. I'll give the time for the copying. Don't write. Please listen, everyone. I'll give the time for writing. Okay. Methanol or formaldehyde. HCHO. This is HCHO. Methanol are also called as formaldehyde. HCHO. Once look at this. Two reagents you will get like this only during the questions. RMGX. Today I sent one worksheet. Okay. H3O plus. Hydrolysis. This represents addition of water. H3O plus means addition of water. RMGX followed by hydrolysis. Methanol produce 1 degree alcohol. Very important. We are preparing alcohols. Okay. 1 degree alcohol is produced here. Next, methanol or formaldehyde. Next, I am taking acetaldehyde. Same. Acetaldehyde when treated with RMGX, Grignard reagent, followed by hydrolysis. H3O plus. If you see H3O plus during the reactions that represent addition of water. This will give 2 degree alcohol. Next, acetone. We will discuss mechanisms also. Acetone when treated with RMGX followed by H3O plus. CH3, OHCH3 and R. 3 degree alcohol. First you should have idea about the type of alcohol produced. Okay, when you will get primary alcohol, when you take methanol or formaldehyde, when you get secondary alcohol, when you take acetaldehyde, when you get 3-degree acetone. This is general idea. This is general idea. Clear? Now let us start the mechanism. No need to by heart any reaction. If I give 100 reactions, then you can write the product if you know the mechanism. Clear? If you by heart this, it is unable to answer. Clear? So learn the mechanism. If you get hundreds of reactions, then you can answer easily. Clear? Let us start the mechanism for each and every. Very, very easy. Very, very easy. So simple. Oh, I have to give the time. Okay, copy. Okay. Let us see the mechanism for the first reaction, for this reaction. Or I'll do one thing. I'll take one example. In place of RMGX, I'll take one example. Methyl magnesium chloride I'll take. What is R here? R is a methyl group, ethyl group, any alkyl group. Okay. I'll take one example and I'll explain. Instead of writing direct general mechanism, I'll take one example. That is better. Okay. I'm adding methyl magnesium chloride H3O plus 1 and 2 RMgCl RMgX methyl magnesium chloride Grignard reagent H3O plus. See the product CH3 CH2OH primary alcohol. See the mechanism. First dissociate Grignard reagent. You know how to dissociate Grignard reagent. Grignard reagent is dissociated like this. See, CH3MgCl is dissociated into CH3 minus and MgCl plus. Everyone should know about a splitting of Grignard reagent. RMgX dissociates into R minus and MgX plus. Explained in first lesson. Grignard reagent, scientist Grignard got Nobel Prize. Explained all the things. How Grignard reagent dissociate? It will dissociate into R negative and MgX plus. Right. Okay. Now take the aldehyde or ketone given to you. Now I am taking this. Okay. Right. CH3 minus MgCl plus. CH3 minus and MgCl plus. CH3 minus and MgCl plus. Right. In carbonyl group C double bond O, which is more electronegative, carbon and oxygen. Oxygen is more electronegative. So negative charge, carbon will get a positive charge. Now oppositely charged species will add together, or oppositely charged ends or parts join together. Carbon plus carbon minus addition. This total MgCl plus, it is a positive, so it will go towards oxygen. This is very important. Splitting is easy only. You should know about addition. In carbonyl group, carbon is having positive, oxygen is having negative. So add oppositely charged species. Negative adds to positive, positive adds to negative. Right? Next. Let us consider it as a step 1, it as a step 2. Later you no need to write step 1, step 2. In the initial stages you have to write like steps, stepwise. Look at this. HC, here O, look at this, O MgCl, O MgCl, okay, and this CH3, here H, okay. Got it, all of you? Aishwarya, did you get this addition? Are you getting, Aishwarya? Unnava Aishwarya? Aishwarya. Other students, Bhakti, follow అవుతున్నావా? Aisha, what about you? Aisha. Step 2 is okay for everyone? Step 2. Step 3. Addition of water. Take this as it is. Take this as it is. H. H3O plus, addition of water, addition of water. Look at this. Stop writing, all of you, look at this. Cut this bond. H2O, how H2O dissociates? H plus and OH minus. H3O plus addition of water. If you get any confusion, you can write here. H3O represent addition of water. Addition of water. H plus and OH minus. Right? Break this. Look at this. HCOH. OH. H here, CH3. And this is MgOHCl, byproduct. Don't bother about the byproduct. You can ignore byproduct. Okay? You can ignore byproduct. So we got alcohol, CH3, CH2OH. This can be written like this also. Both are same only. This one and this one, both are same. Okay, copy. Addition of water is clear for everybody? Addition of water. Vaishnavi, did you get? Addition of water step. Srujan and Aishwarya. Aishwarya, meeku ardhamainda? Aishwarya, respond avatla. Srujan, what about you? Yeah, okay. Srujan, what about you? Adiba, for you? Adiba. Bhakti, Meenakshi, respond out. Haru, no problem. Shall I clear this? Shall we go to next example, all of you? We took formaldehyde and we got primary alcohol. Let us take acetaldehyde. Acetaldehyde. CH3CH4. First reagent CH3MgCl. You can take MgBr also, any halogen, MgI also. Not only chlorine, you can take other halogen. Second one is H3O positive. H3O positive. And the product is CH3CH. It is a 2 degree. 2 degree. Same mechanism. Once if you learn the mechanism, you can apply this mechanism for hundreds of reactions. Okay? Same procedure, everything is same. Dissociate Grignard reagent R minus MgCl plus. Same steps we have to write. Same steps. Okay. Consider it as a step 1. And in step 2, take given aldehyde. CH3CHO can be written like this. CH3C double bond OH. Is there any mistake in this? CHO can be expanded like this. C double bond OH. Next, CH3MgCl, which is positive, which is negative. R minus MgCl plus. Carbonyl carbon is having positive, partial positive. Oxygen is having negative. So opposite charges will add together. R Mg. During addition, double bond will converted to single bond. Between carbon and oxygen, double bond is there, but you are adding 2 species, right? So double bond will converted to single bond. Next, take this as it is. Take this as it is and add water. H3O plus represents addition of water. H and OH. Break this. CH3 C OH OH MgOHCl. MgOH and Cl. Clear? For every reaction, mechanism is same. Can you try with acetone? Try with acetone. Have you copied, all of you? Online students, shall I remove this? You can try this one. Same mechanism, everything is same. I am giving same Grignard reagent also. You try, all of you. Acetone with the methyl magnesium chloride and water. Try all of you. See the product. Look at the product, all of you. What is its name? Give the numbering. 1, 2, 3. 2-methyl 2-propanol. 2-methyl 2-propanol. 2-methyl 2-propanol. 2-methyl 2-propanol is the product. Name of the product. Okay, right. I am taking another Grignard reagent. Every time I am giving methyl magnesium chloride only, I will change the Grignard reagent, and I will change the carbonyl also. Okay, I will take cyclic. Cyclohexanone. Phenyl magnesium bromide, or maybe anything, RMgX, or maybe alkyl group, or maybe aryl also. And see the product for this. I will explain the mechanism. This is the product. Okay, let us see the mechanism. Same mechanism, everything is same. How Grignard reagent undergo dissociation? R minus and Mgx plus. R negative, your negative charge, and Mgbr plus. Okay. Benzene ring will get negative charge. Next, take this carbonyl. This dot means carbonyl carbon will have positive charge, oxygen is having negative. Okay, negative positive, negative positive. Okay, O Mgbr. Here phenyl ring will attach. What is the next step? Adding water. I am taking this as easily. Have you copied these two steps? Take this as TB. H and OH. Break this. MgOHBr is the byproduct. You no need to write the byproduct. MgOHBr. No need to write the byproduct.